Python has several built-in functions that can help us when we're working with strings. So string is a series of characters. They don't necessarily have to be the letters, right? This could have a number one or any other type of character that we can create. When we print this out, we're printing out a list of individual characters. So here I'm saying that I want to print out just the number one index for the character. If we look right here, we count the number of characters. This is very common in computers. We start with a 0. So the very first character is 0. And the second character, which we call index number 1, is a B. So letters at 1 is B. Letters at 4 is E. So even though E, the way we count it, 1, 2, 3, 4, 5, the computer starts at 0. So a very common way to do that. This is a way if I wanted to say I want a specific range of characters. So I want to start at 3, so 0, 1, 2, 3. So we're going to start at D. And then this is kind of a strange way Python does it, but they put the last character, but we're not going to include the last character. So 0, 1, 2, 3, 4, 5, 6. We're not going to include 6. So this will print out D, E, and F. So the 3 here, and then we go up 2, but we do not include that number at the end of the range. Almost all of their functions work with that way. Here we're saying if we want to have a person enter a word, we can actually calculate with the function len to determine the length of the word. So the length of this word is 1, 2, 3, 4, 5 characters long. Here I'm doing a multi-line string. I'm using 3 double quotes, and then I end it with 3 double quotes, and I have it on 2 separate lines. That's going to print out on 2 separate lines. Here we're looking at that we can change the case of a string. So here I have uppercase, and if I wanted to change enter a word, if I wanted to change that, the word dot upper. So the person types in perpendicular, and we make that an all uppercase. If I do word dot lower, and remember I've got to put these little parentheses in here, so word dot lower, that gives me the lowercase perpendicular. This is a find, so what I'm doing here is I'm saying find in the text the lowercase letter C. It's important that we distinguish between lowercase and uppercase. So 0, 1, 2, 3, we have to count this space right here, 4, 5, 6, 7, 8, 9. So this lowercase c is in the 9th index. I can get a little fancy here. So if I add to position, if I change it to a 10, so remember this was 9 because we found that the C was in the 9th index position, and I make it a 10. So now we're right here on the L. And now it's saying find the letter C starting at position number 10. So 11, 12, 13, 14, 15, 16, 17, 18, 19, we get another C, and so we print out 19. So this, we're passing an additional parameter saying where to start looking. Here we have come and clean the chaos in your closet, and we're looking to replace, so text.replace all of the C's with a K. And so this is only going to replace lowercase c's, so all of these lowercase c's are replaced with a K. This one right here is that if I wanted to make that the text in uppercase, so this is going to change all of this to an uppercase because I'm using txt.upper. Here we're looking at the text starting at index number 1. So starting right here, go up to 3, but don't include 3. So just 1 and 2, that gives me a B and a C. If I don't put anything before the colon, that just indicates start at the very beginning. So this will be A, B, C. Remember 0, 1, 2, 3, but don't include 3. So A, B, C. This does the opposite. This says start at index number 3 and go all the way to the end. So 0, 1, 2, 3. So we start with a D and then just include every character after that. This is if I wanted to take out any white spaces, I can use the dot strip. This is a concatenation. It's a fancy way of saying we're just putting these and we're combining them together. So A, B, C, D, E, F becomes this new string A, B, C, D, E, F. We can also concatenate a number to a string, and so this ABC42 can be concatenated against that. This one's a little tricky to walk through, so let's take it slow. In this first string, the big difference is we have the number 1, and in the second string, we have the spelling of 1. And so this in keyword is saying, is a 1, the number 1, inside of string number 1. If we look up here, yep, it's right there. So this is going to print out as true. This says print 1, the number 1. Even though it spells out 1, there is not a 1 in here, the digit 1. And so this one will print out false. I can also do a not in, so this is the opposite. So this one would be false, and this one would be true because the number 1 is not in the string 2. This is a loop that I would go through here, and this is just determining whether or not there is a number in string 1, and it would return, it would print 1 because it would say, yes, there is a number in string 1, and it's looking to see is there a number 1 through 9. A better way of doing that is there's actually a method called .isDigit. So if we wanted to see, is there a digit in the number, then we would use the isDigit method. This one right here is just a way to format the text. And so we use this F prime, so F dash, and then here I'm saying player name, and then reserve 16 spaces for player name. Here reserve 8 spaces for that points. And then this says print a dash, print it 24 times, so 24 dashes. And then right here, we've got the person's name, reserve 16 spaces. So let's see what that looks like. So it's very similar to this where we've added the spaces. This is just saying that we want to be able to put the score in here. So we're printing out the name, and then if it's less than 16, then score greater than 6. Okay, here we're saying we want to put a 0 in place. So if there are not enough characters to make that 6th space, then put zeros in front of it. And then this last one is to put underscores in front of the name, in between the name and the score, or whatever this, score is the second part. So dash, 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 and then score. That's just a way to format the output. We can also format floating point numbers. So here we have pi. Pi is a really big number, and this is giving us a really close approximation. We can get an approximate value of pi. 22.0 divided by 7 is 3.14, and so we get an approximation of that. And then, so here we give the actual pi value, and the second one gives us this really long number right here. And then right here, we're using the approximate pi. So that's this number right here. And we're saying that we want it to be 2 decimal places. So this 0.2f allows us to be able to print that out.